Hello, today we'll be covering stacks and queues. We'll start by the definition of data. Data is a collection of raw facts and figure. Data structure is a representation of the logical relationship existing between individual elements of data. It is a specialized format for organizing and storing data in memory that considers not only the elements stored but also their relationship to each other. Data structures can be classified in two types: linear data structure, which are arrays, stacks, queues, and linked lists, and non-linear data structures, which are trees and graphs. Stacks is a linear type of data structure that follows the last in first out principle and allows insertion and deletion operations from one end of the stack data structure, that is, top. Implementation of a stack can be done by contiguous memory, which is an array, and non-contiguous memory, which is a linked list. Stack plays a vital role in many applications. These are a few real-life examples of stacks. This is stack representation in data structures. A few operations on stacks. Push, that inserts an element into the stack. Pop, that removes an element from the stack. Peek, that returns the top element of the stack. Is empty returns true if the stack is empty, else false. Size returns the size of the stack. Push operation. What changes are made to the stack when a new element is pushed? A new element is inserted on top and the value of the top increases by 1. Pop operation. What changes are made to the stack internally for a pop function? The top element is removed and the value of top is decreased by 1. This is the algorithm of insertion in stack, and this is the algorithm of deletion in stack. A few applications of stacks. The first one is reverse a string. A stack can be used to reverse a string's characters. This can be done by simply popping each character off of the stack one at a time after pushing them onto the stack one at a time. The initial character of the stack is at the bottom of the stack, and the last character of the string is at the top. And due to the stack's last in first out property, after performing the pop operation in the stack returns the string in reverse order. Second application of stacks is converting decimal numbers to binary numbers. A number can be transformed from binary to decimal, octal, or hexadecimal using a stack. Any decimal number can be converted to a binary number by continually dividing it by 2 and pushing the residue of each division onto the stack until the result is 0. The binary counterpart of the provided decimal number is obtained by popping the entire stack. Stacks can also process function calls. In programs that call multiple functions in quick succession, the stack is a crucial. Assume we have a program with three A, B, and C functions. Function A calls function B, and function B calls function C. Stacks help us achieve this smoothly. Stacks also evaluate postfix expressions. Stack is the ideal data structure to evaluate the postfix expression because the top element is always the recent operand, and the next element on the stack is the second most recent operand to be operated on. Postfix operation is 2, 4, 3 plus multiply 5. The following steps illustrate how postfix expressions is evaluated. Now for the second part of this lecture, queue data structure. A queue is defined as a linear data structure that is open at both ends and the operations are performed in first out order. FIFO principle of queue. A queue is like a line waiting to purchase tickets where the first person in the line is the first person served. Position of the entry in a queue ready to be served, that is, the first entry will be removed from the queue and is called the front. Similarly, the position of the last entry in the queue, that is, the one most recently added, is called the rear. Enqueue operation. This operation helps us add elements to the queue, whereas the dequeue operation helps us remove elements from the front of the queue. Now the different types of queues are simple queue, linear or the linear queue, priority queue, double-ended queue or DQ, or circular queue. Simple queue or linear queue. In linear queue, an insertion takes place from one end while the deletion occurs from the other end. The end at which the insertion takes place is known as the rear end, and the end in which the deletion takes place is known as the front end. Circular queue. In circular queue, all the nodes are represented as circular. It is similar to the linear queue except that the last element of the queue is connected to the first element. It is known as ring buffer, as all the ends are connected to another end. Priority queue. It is a special type of queue in which the elements are arranged based on priority. It is a special type of queue data structure in which every element has a priority associated with it. Suppose some elements occur with the same priority, they will be arranged according to the FIFO principle. There are two types of priority queues: ascending priority queue, descending priority queue. DQ or double-ended queue. In DQ or double-ended queue, insertion and deletion can be done from both ends of the queue, either from the front or rear. It means that we can insert and delete elements from both front and rear ends of the queue. Thank you.